change a little bit our requirement and say we want our output to be, we want to have to do the sum of one element and the element right after in the array. Okay, so I will have something like let's call that vec add next. Okay, it just takes one array for input and produces an array of output, and we want to go up to 11, or let's go up to 12. And this is going to be something like plus a at index II plus 1 mod 12. Okay, so for the last one we're going to add the first one. Okay. Let's make it simple here. Missing a comma there. Okay, looks good. Try that. Good. Okay, so 1 plus 2 is 3, 2 plus 3 is 7, 4 plus 5 is 9, 5 plus 6 is 11, etc. And 12 plus 1 is 13. Good. So let's do the same in SCADE. So let's say the first element is current and the second one is next, and my output is my result. They are all integers. And basically I'm just doing the sum. And it's a function. So here if I take A, what is the next? Basically I can take a slice of A and basically say take this array from 1 to 11. So let's see the size. So that's the size 11, that's fine. And I'm going to concatenate that with A at index 0. The problem is A at index 0, it's an int, and I need to say this is an array of one int. So I can simply write it like this. That's an array of one int. And so that's an array of 12 elements. 11 minus 1 plus 1 plus 1 is 12. Okay, let's make some room so it's more visible. Okay, and that's my new C. And I can try this. of course I need to apply a map on this. Okay, so basically this is the A array that is shifted right by one element and completed by the first element at the end. We're going to see that during the simulation. Yeah, of course I'm not using B anymore here. Good. So let's simulate this. I had it already in the watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And do one step. Okay, 3, 5, 7. So if I take back my previous run, you will see 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 13. So we have exactly the same result. Okay, we can look here at what this variable is. For example, let's watch it, and you see that it's basically it's A but shifted by 1. So the first element is at the end, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, just moving everything by. And so that's a way that you can use to access, for example, to the next or to the previous element in an array in the map iterator. Okay, that's pretty much all for the map iterator, and we will continue with the other iterators in the family. So if you had a look here, we see that there are several other iterators. I'll explain them in a later sequence. Thank you. Hey, welcome back on our map iterator session. So in the previous episodes, we have seen a few equivalences between C loops, very simple C loops, and SCADE iterators, SCADE map iterator for the moment only. I've been thinking about this topic, and in the examples we have presented, it somehow looks simpler to do it in C rather than in SCADE. We have seen that there are certain number of checks that are present in SCADE that are of course not present in C, so you have a benefit in terms of safety, for example the checks on the sizes of the arrays. But okay, the level of complexity seems more or less the same, right? It's as difficult to do in SCADE as do it in C. And if you're already a C developer, you might not see a big interest with what we've seen so far in using SCADE rather than C. So we're going to complexify a little bit our requirements and see how SCADE scales up to more complex designs. So I will start by slightly complexifying my requirements. Okay, I want to do something that will take an array of integer as inputs and will run several cycles, exactly like we do in SCADE. And what I want is for every cell in my array, if the value increases between two cycles, I want my output in this cell to be +1. If the value decreases between two cycles, I want the output in this cell to be -1. And if the value doesn't change, I want it to be 0. It's a comparison function if you want. Okay, so let's implement that in C. It's a vec compare function, and it just takes it takes one vector and produces another vector. Okay, and it compares over time, right? So here, in order to still be able to do that simply in C, I will just make a second vector, which is the previous value of A, and it's 12. Okay, so I have explicitly to declare my memory here. Okay, so okay, so if A is strictly bigger than pre-A at index II, then it's 1, else it's -1, else it's 0. Okay, and here, oh, that will start to be a little bit. I will do. Let's call that A1 and A2, and make some different values. So I can keep the same here. Here I can put 1. Here I can put 4, 5, 0. -1, 7, 23. Okay. Okay, so let's make 2 cycles, A1, then A2, then A1 again. So that's 3 cycles. So vec compare A1, A2, C, and so I'm going to compare to produce okay, so let's build this. So my file is +vec. Mistake, line 21. What did I do? Okay, just forgot this one. It should be better. Okay. So we can see that this works perfectly. Okay, great. But here you see that I had to artificially somehow create my memory. Let's do that in SCADE. In SCADE, that's going to be very simple. I'm going to create a compare operator, a compare with past, for example. So in out, and I will have to, I can use, for example, the pre-operator here. So I can compare is my is in strictly bigger than pre of in. So if it's the case, my output is 1. Is it strictly smaller? In that case, my output is -1. Else it's 0. Okay, so you see here that I'm putting the memory inside my operator, and I can do a check, and so the first thing, my types are not correct. Great. And here we have a problem. Our output, what is its value at the first cycle? This is not defined in my current implementation. I can say, okay, at first cycle, I have no memory for the previous value of in. So I can take a convention. I can say, okay, at the first cycle, my output is always going to be 0. So I'm going to initialize this to be 0 at first cycle. I can check this, no problem. So now here I can come, take my comparison operator and apply a map 12 on it, right? Oops. I want to simulate the root operator and not the comparison operator itself. Yep, so this is no more a function because comp has a memory now. Good. So let's take this value for our first cycle. Okay, so we see that our output is 0 at the first cycle because we haven't get the new values. So if I go in every operator, you see it's first cycle, so my output, whatever happens, my output is 0 here. Okay, now let's take this value for the second cycle. And we see that we have 0, -1, 1, 1, 0, -1, 1, 1. Oh, it's a reverse. Okay, I just reversed the condition. 0, -1, 1, 1, -1, -1. Okay, it's exactly the reverse. So let's fix that. Oh, A1, okay, A2 is the previous value of A1. Okay, so actually, if I want to do the same case, I have to start by this one. One step, everything at 0. Second step, these values here. Okay, 0, 1, minus 1, minus 1, 0, 1, minus 1, minus 1. Okay, we have exactly the same. Okay, and then if I want to go back to the previous set, okay. Okay, which is exactly the same. So here we've seen that we can, on the operators we iterate, we can put memory into it. And that's going to be really useful. If you have to do that in C, you see that you have somehow this previous this memory to hold all the previous value. You have to think about it, you have to declare it, you have to know its type, you have to store it somewhere. Think that I avoided here by cheating a little bit and doing everything at the root, but if I have to do that for a real project, I will have to build a structure that is going to hold all my memories. SCADE is doing that for free for you, and it's going to generate the right code for that. Okay. So we're going to complexify a little bit this, so you really understand the benefits of it.